Hi, I'm Wilson Hannon. I'm currently at Palmerston North Intermediate.
I'm Jonathon Hannon. I'm Wilson's dad and have given him a bit of guidance through this project. My role at Massey is the coordinator of the Zero Waste Academy.
Yeah, so the story starts off when we were cycling along the bridle track by the Manawatu River and we came across a stream. When we found the stream, we looked closer and saw lots and lots of plastic. So I decided to do this for my science project.
So there were two aspects to Wilson's first science project, which was in 2016 and 17. We collected, Wilson and his little brother and I cycled down and we collected plastic from
The rocky section.
Yeah.
So then what we did is we sorted through it and cleaned it, and then we put it into its different categories, weighed it, so then we got quite a wide range of data. And that bottom left photo here just shows small microplastics, how we couldn't capture them. And so one example of those is polystyrene balls.
Little polystyrene balls. There was lots of that going into the river.
So this next slide shows all the diversity of the different litter categories that we collected. So one of the main ones was plastic bags and shrink wrap.
So I've just overlaid that just to illustrate. So the government has just announced the proposal to ban single-use plastic bags. So you can see that banning that is going to impact some of the plastic that are in our local waterways, and also under current discussion, local government New Zealand, actually Palmerston City Council put a remit to local government New Zealand. It was supported by 90% of the councils in New Zealand, was to develop a container deposit system within 2 years. Unfortunately, the government said no.
This slide just shows all the data that we collected in the first and second collection, which was a 5 months difference. It just shows it all presented in its different categories by weight up here and by number down here. When you're doing this kind of you've got to do weight as well as number, because plastic is so light, so it has a disproportionate thing, so you've got to look at both of those parameters. What we did to get an idea of how much plastic would be in the whole stream is we collected a portion of the upstream section with the grassy bank, and then from there we multiplied it to figure out how much would be in the whole stream. And just this bit down here shows how much food plastic brands that we had. What we do and don't know. So from the data that we collected in the upstream section, we can estimate that there's around 11,000 separate pieces of plastic litter in the whole stream. So in the rocky section that we collected, there was around about 450 pieces of plastic, and in the 5 months later collection we collected 330 pieces of plastic. So from there we can estimate that in a whole year that section would refill or would get to about 792 pieces of plastic. This year for my project, the first step was to get a better idea of what sort of plastic catches other people have made. So what I did is I made a literature review of plastic catches that other people around the world have made.
I don't know if you've seen the news recently, but the guy in Holland, I think this has just been a prototype, 600 metres long, being sailed out into the Great North Pacific Gyre in order to test the idea of trying to collect plastic from the ocean. The challenge, the reality is, actually once plastic is in the ocean, we've got real challenges doing anything about it.
Yeah, so the next step to this project was to map out all the different streams and still water drains that lead into the Manawatu River. We did this to get a better idea of what sort of pipes and things that would need to fit the plastic catcher design onto. These are just the pictures of all the different streams, one being the stream I did my last year project on, and 20 being the Mangoni stream.
So this just illustrates that if we were to actually try and measure what plastic is in the water column, there's all of these different places that are flowing into the river, and all of these different streams. So the key question in terms of the technology part of this project is, well, can we catch plastic? And because to measure it, you've actually got to catch it. So you're shifting from just understanding the problem a little bit to actually solving it. So shifted into that mode with the next year project.
Yeah, so back onto the other plastic issue, which is wind-blown plastic. So pretty much what happens is plastic gets blown from the Awapuni Recycling Centre and gets either snagged in bushes or just gets blown straight into the Manawatu River. So what we did is we decided to take three is to record it from 3 places, 2 of which were control sites and the third was an area by the Awapuni Recycling Centre.
One is up by the Hukawhitu end of the road by the golf course, which is quite a popular walking area, and the other one is just along from the bridge, in order to compare with this sort of what in reality was sort of this plastic hotspot that we weren't expecting.
These 3 bags just show how much litter there was, and this graph really shows how much more plastic there was by the Awapuni Recycling Centre. I did a little bit more research just around the wind-blown plastic, so we found these 2 other plastic catcher designs for wind-blown plastic.
This just to illustrate that. This is a picture from the newspaper talking about the same issue at Manawatu District Council at their recycling thing, and the farmer complaining that it's potentially killing his stock. And it just illustrates, I guess, from a policy point of view, the wisdom of what our current government are proposing to do, which is to ban single-use plastic bags, because this type of litter, this type of material is basically unmanageable, because it blows in the wind, it blows in the water, and it causes all kinds of problems, and it's there for thousands of years.
What I did once I'd finished the literature reviews, I came up with 3 cheap and easy to make designs. So the first was a net design, the second was a chicken wire design, and the third was a barbed wire design. What we did after that is we tested all 3 overnight in the stream next door just to see if they would catch any plastic, not to test them against each other. So in the morning we found 2 of the 3 plastic catchers, the third of which had flown away downstream and we couldn't find it.
So that design didn't work, and we made the plastic problem a little bit worse, unfortunately. Sorry about that.
Yeah, so the things we found out with the 2 designs that were left was there was lots and lots of organic waste, but there was also a fair bit of plastic, and one of them caught a cigarette butt, which was impressive. Yeah, so from those designs we came up with this design down here.
So this was the design for a proposed next prototype of a plastic catcher that you could put over a pipe or integrate somehow into the river. And you can see it's been laser cut out of stainless steel, so it's not going to rust. It's going to be strong enough to withstand the flood events. And the idea is that actually this has to be, it's not just got to be good at catching plastic, it actually has to be able to be very easy to clean. So it catches one way and then you can rake it clean the other way. So we just illustrated what we thought was maybe a cost-effective technology to start doing something about this.
This slide just shows that it's not just plastic getting caught in our waterways. There's like shopping carts, road cones, there's all sorts of different litter. And that top left photo just shows how plastic breaks down into small microplastics, making it way harder to clear. So after I did my science project, we got invited to E&M to talk to them about this project, and from there we decided to take part in World Cleanup Day, which is happening this Saturday down at the end of Maxwell's Line.
One thing I'd say as a parent is that if you go and do a stream cleaning event, you'll never litter again, okay? Because that's what we need to do, is get our young people involved in resolving this problem and understanding it more.